In this example, I need to solve the triangle in which I'm given side B is 9.3 inches, side C is 12.2 inches, and angle C is 79.2 degrees. I also need to round the answers to the nearest tenth. Well, in problems like these, it's very useful to draw a diagram. I'm not told that this is a right triangle, so I'm just going to draw a generic oblique triangle over here. It doesn't matter which angles I call A, B, and C. I'm just going to label them A, B, and C. But it's important the side opposite angle A is side A. The side opposite angle B is side B. The side opposite angle C is side C. Now to put this information on the diagram, I know side B is 9.3 inches. I know side C is 12.2 inches. Excuse my bad handwriting, that does say 12.2. And angle C is 79.2 degrees. Now quickly reviewing the methods to solve an oblique triangle. I can use the sum of the angles of a triangle is 180 degrees. I can use the law of sines and the law of cosines. But I cannot use the Pythagorean theorem, and I can't use trig functions described in terms of adjacent, opposite, and hypotenuse, because both of these can only be used in a right triangle. So looking at the information I'm given two sides and an angle, but the angle is not the included angle. Angle A is the angle included between sides C and B. So this is two sides and the non-included angle that we write SSA. And unfortunately, this results in something called the ambiguous case, in which I might get no possible triangles, one possible triangle, or two possible triangles for my solution. Now, we always solve these cases using the law of sines. And putting this information on the law of sines, I know side B, I know side C, and I know angle C. So I can use this part of the law of sines to find angle B. Since I'm looking for an angle, I'm going to write this inverted. So going back to my previous slide, I'm going to have the sine of angle B over side B equals the sine of angle C over side C. To get the sine of B by itself, I'm going to multiply both sides by B over 1. These B's reduce, so I get the sine of angle B equals side B, which is 9.3, times the sine of angle C, which is 79.2 degrees, divided by side C, which is 12.2. So now I'm going to have to put this in my calculator. Here is my calculator. It's a TI-84 plus. My angles are in degrees, so I need to check the mode. I'm in degrees, so go back to the home screen. And now I just need to put this in. 9.3 times the sine of 79.2 degrees, 79.2. You must close the parentheses. Since this calculator opens parentheses when you hit sine, you have to close parentheses when you've finished with the angle, divided by 12.2. Hit enter, and that is the approximate value for the sine of angle B, 0.74879, etc. And so to find angle B, I'm just going to have to do the inverse sine of that number, 0.74879, etc. So inverse sine is in blue above the sine key, so hit second sine. I don't want to type this in again. It's stored in the answer, so I'm going to hit second answer, close parentheses, hit enter. So B is approximately 48.4859, etc. And I'm told to round to the nearest tenth. That's the position of the 4. The 8 is going to round that up. So I know that B rounded is going to be 48.5 degrees. Now remember that the sine function is positive both in quadrant 1 and quadrant 2. So there is an angle in quadrant 2 for which the sine of B is equal to this number. But angles in quadrant 2 are obtuse angles. And could angle B possibly be an obtuse angle? Now, reviewing the information we were given, we know that side B is smaller than side C. This means that angle B must be smaller than angle C. And angle C was equal to 79.2 degrees. Can B be obtuse? No, it has to be smaller than 79.2 degrees. So we know that there is only one possible triangle as a solution for this problem. And now to complete the solution for this triangle, I know 2 angles, so I can find the third using the sum of the angles have to add up to 180 degrees. So angle A is 180 degrees minus angle C of 79.2 degrees minus angle B, I want to use the more accurate version, 48.4859, etc. degrees. Doing that on the calculator, 180 minus 79.2 minus, this is the accurate version for angle B, so I'm just going to use the answer key, hit enter, and I get 52.3140, etc. degrees. So I know angle A, when rounded to the nearest tenth, the 1 is not going to affect the 3, so it's 52.3 degrees. Lastly, I need to find side A. I'm going to use the law of sine. Since I'm looking for a side, I'm going to have the side on the top. So side A over the sine of angle A equals, I'm going to use the given information of side C over the sine of angle C. To get A by itself, I have to multiply both sides by sine A. These reduce, and I get A equals C, which was 12.2, times the sine of angle A, use the accurate version, 52.3140, divided by the sine of angle C, which was 79.2 degrees. Running out of room here. Doing this on the calculator, I have 12.2 times the sine of my angle A, which is here in the answer, so put second answer, close parentheses, divided by the sine of 79.2, close parentheses, hit enter. So it is 9.828, etc. And rounding that to the nearest tenth, I get, I'm going to write it up here, A equals 9.8 inches.